Right. Welcome everybody to today's presentation. Let me go ahead and move this tile over here. And is my screen visible to everybody?
Yes.
Perfect. All right, so today we're going to be covering decomposition pathways from green wastes to soil resources. My name is Caleb Griffin. I'm a NRCS soil conservationist, an owner and operator of Lovestead Farms, and a co-founder of the local area revitalization project. It's a agricultural co-op here in Susanville, California. Just a little bit about me. I'd really like everybody to gear up their minds and situate themselves in a posture where we're thinking about the waste that we produce, what comes out of our house, out of our garden projects, our barbecue parties, all that kind of stuff, and really try to envision where that waste goes in the cycle, and how these things that we're going to be focused on today, really play a role in our everyday life. So as a soil con with NRCS, I help farmers and land managers address broad resource concerns. With my farm operation, we produce some worms, castings, compost tea products, and then we sell a number of small vegetables, herbs, plant starters, and we're currently endeavoring on cultivating some culinary mushrooms for the community as well. So decomposition through worms and mushrooms has been a big focus of ours, and with the food cooperative or the farming cooperative that I'm a part of here in Susanville, our main objective is to lower barriers of entry and increase access to local foods, ag products, and we do a lot of that work through community education events. We've got a small education farm in town. But that's just a little bit about me. And if we can all try to frame our mind around where our waste products go when they become waste to us, when we're finished with them, that would really be helpful here. This next slide is kind of a brief overview on everything that we're going to visit today. The earlier portions of this are a little bit more of the hard science, broader perspectives. A lot of this data and information came from resources online, and just years and years of experience testing different things out, kind of combining some information. And then as we get further into the slideshow, it digs into a little bit of my specific perspectives as our farm here in Susanville has endeavored to really overcome some of the challenges that we face with closing the loop on our green waste cycle here in town. And then at the very end, we talk about some success stories and review a couple of examples of how other operations are doing it, because my perspective is pretty limited. We're a relatively young operation. But yeah, feel free to pop any questions into the chat. I've got this little tile view opened up on my other screen, so if anyone raises their hand or anything like that, I will do my best to pause. But alrighty, let's jump into this. So first off, I want to review some of the biotic factors responsible for decomposition. Most of us here know what decomposition is. It's the process of decay or rot, where complex materials just become less complex. Those smaller molecules that that are broken down become more accessible to microbes as they become more small. We often associate death with decomposition, but the decomposition process is actually teeming with life, hence these next couple of slides. So digging into the biotic factors, this is a photograph of a cucumber some cucumber skin with a high resolution, high zoom microscopic photo, showing these bacteria living all over the surface of this. This is actually in a composting pile. And then here's a handprint that just kind of demonstrates how so many of these bacterial and fungal microbes just exist all around us at all times. So just a couple of broad facts about bacteria and fungi. They secrete enzymes in many cases, if they're decomposers, to pre-digest the rotting food materials around them. And that's essentially any organic content. When I say organic, I'm not talking about the USDA certification process. I'm really referring to carbon-based. So generally speaking, things that come pretty directly from nature. Biotic factors are largely responsible for the process, at least the processes that we can really visually see of rotting. So you can see this young apple all the way to an older apple. And what's happening here is that this apple is teeming with life on the inside. Not the apple's life so much anymore as it's the microbiotic life that's decomposing and consuming that apple from the inside. So briefly, just a review of bacteria and fungi. Our bacteria are microscopic, single-celled, invisible to the naked eye. You need some advanced microscopy technology to be able to see them. And they're found in many places, all over the planet, in soil, plants, animals, and even in some really unnurturing habitats, like thermal vents, things like that, hot springs. Now fungi, this includes molds, mildews, mushrooms, and under the ground they form a web-like hyphae to extend their range and to search for more substrate to decompose. The part above the ground that we see here is the mushroom, which its exclusive role as a part of a fungi is to disperse spores. And those spores are very tiny, light in weight, and they can fly very far with wind, which allows those mushrooms to germinate in other locations. So here's a good real photo of, it looks like a log that's been split open, and it kind of shows that hyphal web extending through some compartments in the log as it rots away. Now, any one of these things that we're talking about, bacteria and fungi, there could be an entire lesson plan just on those. So bear in mind that I am touching, just gently on the surface of these kind of things. So on with biotic factors, macroinvertebrates. So that includes bugs, centipedes, insects, worms, and these are other larger species that play a role in the decomposition process. They have the ability to move more freely through their environment and more quickly with their size. And they play a very significant role towards the later stages of composting. But a lot of these organisms play a significant role in the way that decomposition happens in nature as well. So worms are highly active decomposers and reproducers. They're kind of my forte at Lovestead Farms. We do primarily vermicomposting here. We do have some hot pile systems. But yeah, they really like high octane, if you will, high in nitrogen components to eat through. So we work with a few bakeries and restaurants, and we gather their food wastes, and that's really what our worms love to decompose and turn into high quality castings. So red wiggler worms, Icena fetida, those are the species that we primarily raise here at Lovestead Farms. And they eat between half and 100% of their body weight each day. which says a little bit about how much biomass they produce, through their castings. And that's kind of the end goal with most worm farming operations, is to produce those high quality castings that can be used to amend soils. Many worm species are hermaphroditic, and red wrigglers are also part of that grouping. And this process, their mating process, results in 2 pregnant worms after it's complete, which is part of why their reproduction is so high. Populations can double in as little as 60 days in optimal conditions. And yeah, they really are excellent worms. This photo is not my photo, but it's a beautiful cluster of worms that I come across pretty often in my operation. And there's some photos later on in here of our Lovestead farm operation. So moving on into environmental factors involved with decomposition. I'm really focusing on the environmental factors that we specifically monitor in our composting process. So just to touch a little bit on nature's process, if you think about a forest floor and how a forest ecosystem works and how it perseveres, the dead materials fall usually on a seasonal basis, or even on a consistent basis if we're in like evergreen forests where they constantly shed leaves. But these dead plant materials are constantly building up on the ground, and within the ground, these soil microbes and fungi interact with each other, as well as with the macroinvertebrates, to help break down that layer of duff from the base. And that's why when you kind of dig into the soil, you smell that kind of sweet, organic acid rich smell in a nice, thick forest soil. And a lot of what that is it's actually surface level composting happening right there. It's a different kind of rate though when it happens in nature. And we're going to dig a little deeper into the specifics of composting on our next couple slides. So oxygen is a key component, a key environmental factor in the breakdown process. The faster working or aerobic decomposers that rely on oxygen, they breathe much like other organisms, and with a consistent supply of oxygen, they can work faster and better to essentially break down whatever it is that we're trying to intentionally decompose. Anaerobic decomposition is also possible. It takes place much more slowly, and it generates a different set of byproducts, one of which is methane, which is a much more potent greenhouse gas than carbon dioxide, which is the main gas release process associated with aerobic composting. Moisture is also key to the decomposition process, especially when many of these dead materials that make it into either the ground to decompose on a forest floor or into our composting system, many of them are dry, old, decadent. So we have to moisturize those materials to make them palatable for those organisms to break down. And temperature. So temperature in the composting process is a really strong indicator that you have some active decomposition happening. We're going to talk about the phases and the temperature phases that help us to identify what our compost is doing throughout the process. And yeah, different types of microbes sustain themselves better in these different types of, or these different stages of temperature throughout the composting process. So we'll dig into that a little deeper now on this slide. I guess one thing I did want to close with before we jump into composting specifically is that, many of our home waste that we release either into the landfill or into our backyard, or for our own composting stuff. But much of what goes into our garbage can that has the potential to be decomposed in a composting system, it ends up in landfills. And within these landfills, anaerobic conditions are a little bit more easy, or a little bit more prevalent in the process of decomposition there. So that's one of the main drivers and motivations for asking ourselves, how can I get more of this compostable material out of the landfill where I live, and pretty much into a different kind of system that results in fixing carbon and storing carbon versus releasing methane. All right. Can you all still hear me? My computer just glitched.
We can hear you, Caleb.
Excellent. Okay, and in this photo here, actually we'll talk about what this is, but this is actually a system where they're pumping oxygen so that they can aerate the pile from underneath. So we'll learn a little bit more about that here in a couple slides. So to dig into the composting, this photo kind of depicts the generalized process. We start off with some compostable biosolid material, high in carbon usually, or an organic based material, and that goes into a pile. It can be mixed with grass clippings, essentially a newspaper. There's a lot of things that are considered compostable solids. And then once they become associated with some decomposers, some microbes, macroinvertebrates, they can start to break down that material. Temperatures build, and a different sort of microbial activity begins to take place, and it climbs through a couple of different phases over time. And then once all the time periods pass by, the compost cools and cures, we've got this nice pile of basic nutrients that we can then apply to our soil. So a few key points of composting: it creates new life from what death leaves behind. It's essentially facilitated decomposition, and it's essential to the nutrient cycle. The target carbon to nitrogen ratio is 28 to 40 to 1, which is kind of how we set up a lot of our decisions in terms of what materials we're going to mix with what. There's common information online to find out, what coffee grounds are. I believe they're actually around 30 to 1. So coffee grounds, in terms of carbon to nitrogen ratio as they are almost the same as a finished compost. So, if you have like a bunch of wood chips that are probably around, 200, 300 to 1, because those are such high carbon, so much woody material, you would want to mix those with something that's higher in nitrogen, that's a little bit lower on that carbon to nitrogen scale. And those are kind of how we combine our materials, make our decisions on what is going to be able to compost with what. The total time frame that composting takes is about 3 to 9 months. And these are the main 4 phases that we look after and that we measure. These numbers vary a little different throughout lots of different composting operations, but this is pretty close to industry standard. So our mesophilic phase, this is kind of our building phase. We may have had some worms, some bugs, some macroinvertebrates crawling through the pile, beginning to break things down. And now we have enough contact between all the materials in there to where the microbacterial life and fungal life is just teeming. and it produces heat as a byproduct in the mesophilic phase. As that temperature passes 111 and goes, up into the 120s, 130s, 140s, we've left the mesophilic phase, and there's not so many fungal actors in this phase as much as it is heat-loving bacteria. Now in this phase, if you just let things go, and there's plenty of moisture, there's plenty of nitrogen and carbon materials, and the microbes are loving it, they're producing a bunch of heat, you're measuring heat off of your pile, you can let this go. But oftentimes what can happen is the heat can get so high that it kills off some of these beneficial microbes. And it kind of forces your pile that may not be completely finished, because that heat was kind of centrally located in the pile. It can force it into the cooling phase and then start curing. So during this thermophilic phase is the key, to provide additional aeration. When we start seeing that 155 temperature getting up into this range, that's whenever I'm, recruiting my friends to go out to our hot piles with pitchfork and let's get these things aerated. Let's get them turned. That way we can maintain that temperature. And it may bump your temperatures back into the mesophilic phase, and then it'll bump right back into the thermophilic the following day. But it's key to get your pile turned, aerated, mixed in together, get those finished compost materials mixed in with the not finished materials on the outside of the pile. And that not only helps with more evenly distributing the activity that the pile is going through with the microbes and fungi, but it also provides that aeration need for a lot of those bacteria as well. After our thermophilic phase, most compost recommendations specify the need to do 3 to 4 turns while it's in the thermophilic phase. And this process can take about a month to 2 months in the thermophilic phase. And then we jump into the cooling phase. And that's whenever mostly everything looks like it's pretty well decomposed. There's probably some large woody materials still. And when I say large, I mean like, fingernail sized twigs, wood chips, things like that, maybe leaf litter, things that hadn't, necessarily broken down. Usually the high carbon items are the things that are left behind when we're here in the cooling phase. And then now in the curing phase, or in the cooling phase, that's when our macroinvertebrates move back in to get back into their action and consume some of those things that are left behind from the thermophiles and mesophiles. And then that curing phase, it's just kind of a stabilizing period. It allows some of these slow degrading high carbon materials to break down. The organic acids and some of the available nutrition in that compost becomes less volatile, more stable within the structure of the materials, so that it acts kind of like a slower release fertilizer as opposed to like applying raw manure on your soil, which provides a little bit quicker nitrogen release and whatnot. And then it also offers the pile a little bit of a chance to further neutralize our pests and weed seeds. So if you have any bacteria that act as a pest for the vegetables that you want to use that compost for, you definitely want those to be killed off. So that's part of why the thermophilic phase has to be maintained for that period. If you let it build through and then force itself into cooling because it killed off all those good microbes that are producing that heat, we've kind of held ourselves up in the process. Last year, I had a handful of piles that I kind of let go in the thermophilic phase. I was really busy and had a baby coming, and those piles just went straight through without any turning. And there was probably a little bit of anaerobic decomposition at some points of the process. And the need for aeration wasn't met the need for cooling wasn't met. So you kind of have to pick back up and start from scratch when you do that, and just re-aerate the pile and keep an eye on your temperatures to see if you can get it through these phases in an appropriate order and time. So that's basically, a description of hot pile composting, the primary method that most folks use. And here we're going to dive into a couple other methods. So here's just a photograph of a large hot pile or windrow operation. The really larger scale and well-developed operations will actually have PTO-driven, tine systems that kind of spin to work the compost and turn it. And you can see there's likely some fungal spores and steam coming off of this pile because of the temperatures that are built up prior to turning. And that's where that sort of large equipment is really useful when it comes to doing things with large scale. Our second option here, we've got static aeration. So they've got a little air pump in this shed that is essentially pushing fresh air into the base of this pile. They call it static aeration because the pile can be aerated without having to move. And this is a system that I'm very interested in. I'm looking into developing on my own, but it does seem to be more and more popular in recent years. And vermicomposting on a larger scale, this is kind of what some of those operations look like. Walkways down the middle with some worm beds that essentially have soft materials like peat moss, cocoa coir, that kind of thing that worms can easily crawl through. And then you would just add your food scraps into this, maybe do a little bit of mixing to make sure everything is touching the soil particles and worms can access it. And I'm not sure if these are like screening mechanisms, but I have seen some operations that have screening mechanisms that can be, when you have an area of a bed that's been finished, it's been checked, you can essentially take and shovel that into your screening system, which has an oscillating motor and can shake the good finished castings out of the material without having to lose your worms. And then the fourth system here is our bin or small scale composting. And this is how I got started. I still have many of these all over my yard and community garden and my friends' places. And this is the best way to compost at home. If you're dealing with a single family's household waste, it's actually extremely easy. You can make a lasagna or a casserole kind of between high nitrogen and high carbon materials, like a layer of wood chips, and then a layer of fresh grass clippings, and then a layer of dried dead leaves, and then, a layer of some kitchen scraps. And if you build that up, search for warmth, every so often dig your hand in there. And if it's almost too hot to touch, it could be an indicator that you might want to turn that pile, and that can help speed up your composting process. And then here on the right is an example of vermicomposting. I don't know if anyone's seen the worm towers that they sell online, but they're like a little worm habitat. It just has these trays that come in layers, and they have holes in the bottom. So at the very bottom tray here, I took and filled it with cocoa coir and worms and some sawdust and just a really nice bedding without food. And then this next row up, this bin that you're looking in here, I filled it with a little bit of cocoa coir and some stuff to help build up the bedding and substrate as it breaks down. And then I just put a bunch of raw food kitchen scraps. Some of these things were pretty smelly and rotten at this point. And in the process of 4 months, those worms crawled up through the holes in this bottom layer and consumed all of this stuff and turned it into that, which is the marketable product in most composting operations. Now the scale of this is also good for, you know, a single kitchen scale, a small family or a bachelor or bachelorette. But I think that if you eat a lot of vegetables, or you're dealing with a larger family, you know, you really need enough space to do something like this if you're going to be doing it at home. And there's lots of other bin systems where you can do it in garbage cans that have holes drilled in the bottom for aeration. They even have compost tumblers out there that have their own stands with a handle that you can kind of rotate to help along with the mixing process. But here's just a few examples of composting. Please dig into this on Google, and I'm sure if you have an interest towards composting, there's so many great different styles of operations out there. I've seen some folks who use mechanical pulley systems to essentially do a single turn on a pile in the middle of it that, you know, would have taken hours with a pitchfork, and they're able to just do it with a handle crank. So there's some really neat innovation happening in backyards across the world with composting. Okay. And jumping on to motivations and benefits. So this presentation's a little bit more, or this portion is a little bit more specific about my operation and the drivers that we find to keep going through the hard times, through the whole startup challenges. And most people don't want to just take a second job for the sake of having a second job. It's, you know, there's usually some reasons behind it. One of those reasons is economics. I know that there is economic viability to selling these worms, the finished composting products. We sell these tea bags also to make compost tea products, and we print fertilizer reports based on the batch so that people know what they're putting into their garden in terms of nitrogen, phosphorus, and potassium before they buy our product. And then, you know, the healthy food and community aspects. Last year was our first year participating in our local farmers market, which was just extremely rewarding. And being able to grow so much of our own food. I got to admit, since I've really gotten on top of composting and managing worms, I've really spent very minimal money on fertility for most of my crops in the garden. And we've gotten to the point where we're bringing crops as well as our castings and some of the other products we release to market. We also sell our subscription service buckets there, you know, where we have subscribers who sign up if they don't have space of their own to compost, but they want to support upcycling the green waste in our community. They can compost vicariously through us by providing us our green waste, and then we exchange, or they provide us with their green waste by the 5-gallon bucket, and we exchange that 5-gallon bucket for a half quart of finished worm castings. Ultimately, though, the main reason that I got into this and why I continue to get into it is for soil health and sustainability. Composting and using this stuff as a soil amendment really brings a lot of benefits to garden spaces and food production spaces. Increased soil water holding capacity. It acts as stable, slow release fertility. We gain increased soil resistance to erosion and compaction, mainly through the process of improved soil structure and aggregation. This kind of material definitely supports our soil microbiome. You know, you still have a lot of living macroorganisms in many cases when you apply it to the garden, as well as microorganisms, beneficial fungi and bacteria. It's a decreased risk of nutrient loss as opposed to a lot of other fertility options, like synthetic fertilizers that are highly water soluble and can run off more easily than a composting fertilized system. And yeah, the overall reduced use of fossil fuels in landfill space. A lot of fossil fuels are used on, transporting our green waste and that weight, from the point source all the way to the landfill, as well as fossil fuel use in terms of producing synthetic fertilizers. And yeah, the carbon sequestration benefits. Every time we're adding, converting things that would otherwise be converted into methane at a landfill site, and we're converting them into a solid form of carbon that can then go into the soil and continue to effectively store carbon from the atmosphere over time. It can act as greenhouse gas mitigation. And overall, it's a higher efficiency of a community waste stream. I really like the idea of being able to find value in something that other people consider waste. And it's been really amazing finding people who find value in using me as a waste catchment, as opposed to them having to use other resources to dispose of that waste otherwise. And especially when it comes back full circle, and they can see the benefits of, having increased accessibility to these products in our community. It's been kind of magical developing this business here in Susanville the last couple of years. I guess one last thing that I didn't really have much space left on this slide is, the desire to really to raise my kids in a way that connects them more closely to food and land that food comes from. A little bit more exposure than I had is a real driving, motivating force here. And then pictured here, we've got, this is one of our layers. So I mentioned earlier making kind of a compost casserole in that crate. So this is some rotten food waste that we got from a local grocery store. And we were layering it in with fresh leaves with old dried leaves last fall. We essentially just gathered leaves from as many neighbors as possible. And then I went into my worm pit that was currently finishing at the time and almost ready for screening. And I just got a big old handful of worms and distributed around this pile. And actually, I believe I've got an interesting photo of that pile. Nope, it's coming up. Right here. Yeah, so I made these two piles together last fall, and the one on the left I added worms to. The one on the right had no worms. So I wanted to kind of create a side-by-side demonstration to really see how effective worms are in a system that can function as a hot pile composting system. And yeah, it turns out that they kind of help the process, especially in a small scale. So yeah, that's a layer of worms in that actual pit that I just showed you a picture of. And then this is our hot pile composting system. We've partnered with a local brewery in town, and we've got 2 of these IBC containers. So when he needs to empty his brewery sludge from the septic, which is where all their brew waste gets stored and captured, they pump that brew septic into these tanks and forklift them over onto these pallet stacks. And then we gravity flow to provide moisture to our piles. And I'm really proud to say that in a year and a half of working that site, we've probably created, we're in the process of finishing up 2 of these piles, or 3 of these piles actually. And we have not had to use any water at the site because of the access to this brew waste. And that's been a really amazing turnout in terms of partnership potential for the community too. He has a way to get rid of this material that he would have otherwise been, pumping into his back field, which leaves an odor. whereas it's really high in nitrogen. So it's great for me to use on really wood chip heavy piles. And I've been able to compost piles of wood chips with a lot less available nitrogen than I thought was possible, because of the access to this material. So it's yeah, that's been a really great success story personally here. And then these two pictures here on the bottom is kind of a demonstration of how I currently screen out my castings. I've got this contraption hanging from my garage rafters, and I bring in usually 25-gallon bins from the composting pits that I'm ready to harvest, and I empty those in little by little into this and shake it back and forth and pull out my tarp and then dump it into buckets. And there the composts castings get stored until I'm able to further process them either into tea bags or just into, or we save a lot of bulk castings that we just sell on a bucket scale or on a by the pound scale. And yeah, so I guess jumping into some of the regulations and laws that govern composting systems. I know that many states have their own kind of specialized permitting system. I know that I am exempt from a permit because of my current operation size being less than 500 cubic yards. But there's a lot of different limitations depending on which state you're looking at. There may even be county specific regulations. I'd imagine, especially in areas that are, close to major waterways and such. Local environmental health permits, if your operation meets a certain size criteria. I don't have that off the top of my head, but I believe I have the link in the references there. If you're so if you meet a certain size criteria and you take in a certain percentage of food scraps, there is a requirement to follow or to get certain local environmental health permits. Those are usually done at the county level. And then our regional water quality control boards also has a permitting or an approval process. And I believe that it is also size dependent. But you must demonstrate that that there is no risk of producing runoff into waterways. As you know, we're decomposing biosolids with the intention of creating nutrient-rich compost. So we definitely don't want those things running off directly into water and creating point source pollution issues. And I included this one in there because it is not at all as much of a challenge and barrier as much as it is a big future opportunity. But this is a new law that came out in California. I think it's actually been around some time, but we're really beginning to see it manifest in a lot of communities lately. And California Senate Bill 1383 essentially requires that municipalities have to upcycle their green waste. They have to have some sort of a program in place that turns green waste into a useful resource for their community. And I believe most people are meeting these provisions through composting, but there could also be some energy conversion pathways that people take advantage of. I know that a couple of our local grocery stores here in town actually export all of their green waste. I've tried to get my hands on it a number of times, but they actually have a partnership between their food chain and an energy company that I believe anaerobically digests the materials to produce methane, which I believe they then burn or store it or do something with it for energy. But it's a different energy production process than composting. And in terms of our resource limitations, I think currently in my system, it's heavy equipment. The ability to turn your piles when they're large piles, like at my brewery site. It becomes extremely difficult when it's just you, your back, and a pitchfork. loading those materials. I don't think I'm going to be able to convince customers to leave their truck parked out there for a half a day if they want a cubic yard, because it'll take a while to shovel and load. So getting some kind of a backhoe equipment or a skid steer, some sort of a front end loader, that's kind of next on our agenda. And then packaging, sorting out the green waste. As Senate Bill 1383 begins to affect these different communities throughout California, essentially customers within these cities are going to be asked to, to start using another green waste bin. And from everything I've seen with large scale operations, especially in more urban areas, you really need to have a pre-composting sorting system to separate the plastics and non-compostable materials from the good stuff that you want to make it to your pile. So that's another resource limitation in terms of infrastructure. Right now, as it currently stands, most of our Lassen County green waste goes into either green bins or in people's trash cans and then goes up into the landfill. So I've been trying to build all these partnerships that I've mentioned throughout. And I think our next slide talks about some of those partnerships a little bit, expressly to increase my accessibility to high nitrogen, clean green waste. But we're also currently partnering with the company that manages our landfill system here to see if there's a way that we could take advantage of the delivery or the green waste pickup system that they already have in place to obtain some of that stuff and procure more of that. And then obviously space and time. As you can see from the heavy equipment in those previous photos, it definitely requires a fair amount of space. And thus far, this has really just been a kind of a hobby business. My teenage son absolutely hates when I tell him, hey, go and grab a pitchfork. We're going to go and do some pile turning today. But there are plenty of other rewards that come along with it. But yeah, those are some of the limitations and challenges there. In terms of the future of our waste cycles, I think that, and I guess one last thing for challenges and barriers. I think one of the biggest resource limitations is that actively sorting and separating compostables it's a change for most people. So I do feel that, our ability to educate and to inspire community members to want to help close these loops and systems, I think that that's really going to be a huge part on a community by community basis of who's successfully able to overcome these challenges and barriers. And I know that after Cal Recycle came and presented to our county just a couple of weeks ago, there was just so much pushback about how many bins will it take, and first there will be one more bin and then how many after that, and who's going to handle this. And there's a lot of concerns about the public won't be willing to separate these things. And yeah, it's kind of a surprise to me, because the last 5 years I haven't really thought about living in a way that doesn't involve sorting and separating and composting green wastes personally, but it's been one of the big challenges, and I look forward to seeing how we can overcome that one specifically. Now, for the future of our green waste cycles, I think these things here on the left are a big part of what makes or what brings a lot of success and to different green waste companies and really community green waste systems. Partnerships, there's local waste producers that are happy to give me their green waste as long as I'm happy to pick it up. Government bodies, we do have a local RCD that I've recently partnered with to provide an educational workshop out at our composting site to a bunch of local farmers and ranchers. who, many of them showed up and were pretty excited to learn about how they probably have most of these source materials to be able to do hot pile composting on their property already. So the idea of being able to decrease the amount of imported fertility, those kind of things is really great. Grants. I'm currently looking into a bunch of different grants and working with the county, the city, and the managers of our dump site to see how we can make a partnership work for me to get that green waste to my worms. In the resource links, you'll find tons of opportunities for CalRecycle, EPA, and USDA. Grants.gov is a great place to search for grant opportunities. And if you type in composting or green waste into grants.gov, you'll find lots of different past and current opportunities. And then community sponsorship. I think it really takes a lot of, like I said, that kind of grassroots effort where people realize that, there's more of a reason to do this than just to help the worm farmer. It's about closing the loop on our carbon footprint and really bringing a better economy in the way that we manage our green waste systems here to a community level. And for instance, that site that I use at the brewery, it's essentially a free lease. It's a handshake agreement under the premise that, hey, if you keep using my brewery sludge, I'm totally fine if you have the local tree trimming services dump wood chips here, and if you bring and gather leaves, and it's just been really great, learning to develop this process here in a place where no process currently exists to upcycle green waste. We work with 5 to 10 landowners, local brewery, sandwich shop, bakery, a flower shop, 2 coffee shops, and a grocery store here in town. And we're developing partnerships with the fish hatchery to see if we can get their pond scrapings, great nitrogen source, our local prison system, the city and the county, through the green waste requirements that these municipalities are going to be facing, as well as the school districts and our landfill operator. So things are really exciting in the way that we're growing over here in Susanville. There's a lot of different models that this can look like, establishing a successful green waste upcycling system. And I've got a short video about Prescott, Arizona, and how they manage their green wastes. Let me make sure I'm sharing sound. Yep. Okay. Can everyone hear?
Yes.
Excellent, thank you.
This is not just a market to sell things, it's a market to help the community as well.
The community feel is really there. It's a lot closer, a lot tighter knit. You see people, you smile, it's, hey, how are you doing? Oh my, we love that here.
Composting gives the community an opportunity to learn about alternatives to how to manage their waste.
What I really love about this compost program is our trash is so light and it makes me feel good giving back now that we have a community compost.
I couldn't imagine a year ago that this many people would want to volunteer their time to come throw around some food scraps and straw and leaves.
Now we mix.
It's just really inspiring.
I'm on the board of the Prescott Farmers Market. It's a vibrant, alive organization. A lot of new programs. This composting program is my favorite. The USDA, Natural Resources Conservation Service, provided funding through a grant and featured little Prescott, Arizona, and what Gabriel's doing here. And I just love coming out and meeting new people and digging in the dirt. It's great fun.
Composting is really valuable, and anybody, I think, just reducing the trash going into the mainstream landfill is A, really important, but B, I think just that awareness of like, oh, any plant scraps can turn into something valuable.
I'm enjoying the sweet smell of compost and good company.
So to do it through here is awesome, and I love being able to pick up a clean bucket.
It helps me think about the environment. You know, I think it's a great thing that they're taking the food scraps from restaurants, because that's one of the biggest wastes. So much food goes to waste, and I think this is probably the most pure, best way you can get rid of all that waste. Turn it into food for your plants.
And my wife's kind of funny. She calls it now it's my compost church. I come here every Sunday and bring you bread, and it's fun just being around people.
The science that goes into making good compost, it's relatively straightforward, but it has to be done kind of precisely. And that's what's happening here with the temperature, with the air handling, with the mixing, with the water.
Then I do the squeeze test, right? So I squeeze it pretty hard. It kind of doesn't want to hold together, but it just barely holds together. So that's like 45% moisture.
All these little steps that go into turning raw organic material into soil are happening here, and people are learning about it.
It feels good to meet people in the community who care about different things, and I don't know, to just do something that you know you don't have to do, but it's worthwhile.
I wanted to learn more about compost because I wanted to volunteer, because my compost bin doesn't do so hot. It's actually too cool, I guess.
Composting is contagious. It's just something that everybody can get behind, and I think with climate change and environmental concerns, a drought, people really want to be doing something, even if it seems really small, to be making a difference, and this is one way that we can provide something really valuable to the community at the end of the day. People are so excited to bring their food scraps to the market.
It's just beginning, really, and people are really embracing the program. They're providing the raw materials, the city, the county. It's just a perfect partnership, and it will only grow. When people hear about it, they're like, oh, this is so cool, you know, and particularly when we have the finished product and can begin to distribute it back to local gardeners for their own backyard. And in this dry climate, you've got to use this enriched soil through compost to really grow good vegetables.
I was impressed with the Green Market in Manhattan. They had a compost program going there, and I thought, if you can do it in New York, you can do it in Prescott.
Oh, let me unmute myself. All right, so that's Prescott, Arizona's composting project. I've actually reached out and spoken a little bit with Gabriel about trying to actually apply for this same USDA grant here. But yeah, there's a couple of other examples here. I know we're running towards the end of our scheduled time, so San Francisco, this is a little article that talks a little bit about San Francisco's program and their goal of 50% diversion from landfills by 2000. I believe they met that and went on to exceed that goal. And I believe it was maybe sometime in the mid 2000s that they set the goal for 75%. But yeah, it's a pretty neat article that has some stats about how their program worked. Anchorage, Alaska, just received another grant, and yeah, they intend to get 25% of wastes outside of or out of their landfill through the process. And yeah, there's a lot of different ways this can happen. Community volunteer-based systems, a lot like Prescott, as well as systems like this, which is likely what I may end up setting up here in Susanville, for people to pretty much voluntarily come and dump their compostables. And I would just do a weekly pickup, something along those lines. So I've got a couple of pages of references and useful info here. Feel free to tab through them and check out some stuff. Here's our little our demonstration that we have for the compost tea when we go to market. And yeah, that's a lucrative composting picture I sent to my wife on Valentine's Day. The pile was too beautiful to not get a photo with it. But yeah, I'm happy to take any questions. I've got my contact information listed here, my phone number. I'm happy to yeah, answer any questions specifically about our operation or about composting, and I'll give it my best.
Caleb, this is Javita. I want to thank you ever so much for such an inspiring and enriching presentation on the science of making compost. I was delighted to learn so much, and all of the study links and resources that you've provided to our Envirothon teams will go very, very far. So my question is, and I'm trying to link some of the stuff our students have been exposed to in terms of other study topic areas, is in your experience in doing your composting operations or vermicomposting and your knowledge, what has been your experience in hearing any complaints from the public about odor or impacts to wildlife or the attraction of vectors to your composting sites and piles, et cetera?
Yeah, that's often a topic of concern when we have workshops for the public. And I think the largest concern that we've actually come across here in Susanville has been wildlife. And in a lot of cases, it does attract raccoons. I've had some locals who've told me about bears getting into their compost piles, especially when they have fruit waste that goes into it. But yeah, overall, in terms of odor, you know, like I mentioned at the brewery, this process actually neutralizes that odor much better than the evaporation process that they were utilizing before to essentially just get rid of this brew waste through leaching it into an open lot. And what I found is that as long as everything is capped with a clean layer of high carbon materials, you're in pretty good shape to neutralize odors for the most part. And the key to eliminating those vectors, you know, for plant pathogens and, you know, even human pathogens, that kind of stuff, because we know, looking at some of the food scraps that go into these piles, that, yeah, that would make me sick if I ate it, right? The key to making sure that those things are neutralized is to reaching those temperatures in the composting, you know, to maintaining it between 111 and 155 in temperature, aerating it and trying to maintain it in that window for 3 to 4 weeks, essentially, is what really does a lot of the killing. And then in the curing process as well, I think those are kind of the keys to preventing those risks from happening. And a lot of times I'll have a compost that's not cured, and I really, you know, I'm ready to make some money for all my time and putting into that compost, but I really have to do, you know, bring forth my patience and know that it's worth it in the long run to give it the extra 2-3 months that it needs to cure. And it results in a product that's so much more beautiful and desirable and effective at providing the nutrition and all the things it needs to. But yeah, I hope that answers your question completely.
Yes, thank you, Caleb. So the floor is open to questions.
So I got a question. The composting programs you're talking about, are they dealing with like food waste from restaurants, including you know, meats and bones and stuff like that?
Yeah, I think that some of these community composting projects, like the Prescott one, I know that they take kitchen scraps and they're working with local restaurants. I really haven't dug into whether they accept meats and stuff. And I know that there are some operations that accept meats. It's a different kind of chemistry.
Right.
So I personally, you know, I have these labels on my buckets here that we send out to folks. and it has a yellow list on one side that says waste that we do not accept, and animal products is on there. Just because the small scale vermicomposting that I'm trying to do doesn't always necessarily reach those ideal temperatures.
Right.
And I know that on rotten meat, there's probably some extra funky stuff that I really would rather not mess with.
Absolutely.
But yeah, as for my NRCS experience, we've contracted and worked with, dairy operations for anaerobic digestion systems, as well as for, animal corpse composting systems. Large cattle operations are also able to do that. So I know that there's a lot of information on decomposing dead animals and dead flesh, but it's a little bit different of a science. And
right.
Yeah.
Thank you.
No problem. I think one day I'd like to get into that. I've always told my family that when I die, I want to be fed to my worms and then, used as fertilizer on a tree someplace that they can come back to and visit all the time, and I'll live on through the tree. But I wouldn't want to put my family through the process of having to compost me.
I have a question about whether you've done any experimenting with integrating municipal biosolids with your compost operations.
I have not. That is something that I'm fairly interested in. I've currently got a 6-month-old, and we're doing the whole reusable diaper thing. So I'm really hoping to have a spot outside that I could, make some human oil and experiment with.
Like she is a danger to herself or others right now?
24 hours a day.
Get the protective order.
Somebody put their microphone on mute, please. We're listening to a radio broadcast.
In Maryland.
Instead of using the word hotline, we use the word warm line so that anybody can call.
Voted the #1 crisis intervention team in the world.
Will somebody put their microphone on mute?
Mental health first.
How can we be helpful to them at that moment while they're in crisis?
Is this the one from the other day?
Lieutenant Steve Thomas heads up the police side of the unit.
Somebody,
Dan Corbin heads up the mental health side.
Officers in patrol can call in for a mobile crisis team. It's their
discretion. Do you think we've gone over time, Caleb, or what's going on?
It could be homelessness.
You know what's going on is I left this Vimeo window open.
Oh.
And it automatically.
Like the dog.
It automatically started. Yeah, don't look at my extremely messy desktop here.
But I like the dog. Okay, so my final question is, have you explored partnerships with low-income communities in terms of collecting their organic residuals and offering them compost for community gardening so they can grow their own food?
Yeah, so the food cooperative that I mentioned earlier, the local area revitalization project, that operation, we manage a site here in Susanville. It's a community gardening site. And then we also just built up an education farm last year in a neighboring town that's a little bit more rural. But yeah, we've effectively established an MOU with the city this past year to make a bunch of on-site improvements to our local community garden area, produce washing stations, actually getting some good solid restrooms established, maybe building some more sturdy composting infrastructure so we can have like a bin type system that isn't completely funded by gardeners. So we've been making a lot of moves to increase the accessibility there. And I would say that that particular site is a really, really incredible example of the power of community food production. We have, I believe we have 5 or 6 homeless individuals who are part of our garden. And then, families from all walks of life, 23 gardeners last year, or 23 families utilized our garden system last year. And if you participate in the community garden, then essentially you're part of our on-garden composting process, where we have 2 or 3 different worm bins. We have a small rotating swivel like garbage bin, and then we have 3 different hot piles there as well. And yeah, we put on all kinds of educational workshops, you know, like when we do a pruning or you know, weed abatement workshop, we'll usually rent a chipper or a grinder to be able to chip those things down and make a new composting pile out of it. And yeah, so those opportunities are there, and that's one of the most, I think, inspiring and driving aspects of what we're trying to do with both composting, food production, and really lowering the bar for accessibility to bring people closer to their food, closer to their soil resources, and closer, you know, to their community's sustainability. It's paid off in dividends. And yeah, I hope if nothing else, you all gathered from this that it really is worth it to, you know, to bend your mind and give composting a try on your own. Because I did it just in 5-gallon buckets when I lived in an apartment, and it wasn't the prettiest and it didn't smell the best all the time, but nonetheless, that's kind of how I fell in love with composting. And that's my main sales pitch for this, is that there's no reason that any community shouldn't be composting. And yeah, that's one of the many ways it pays off, is being able to serve those who need it most and need accessibility to these kinds of tools in our community.
Okay, I see no questions in the chat box. So before we close, I want to ask any of the students who have joined us if they have anything to ask Caleb in the last few minutes that we have, please.
I'm also totally fine to take emails. This number here is my cell phone, so texts or calls, any questions, any kind of follow-up, I'm totally happy to field that. And I love talking about soil, worms, and yeah, it's really been an amazing experience. Participating in all the stuff that I've been able to here in our community, and with making all this green waste upcycling happen. And yeah, it's an honor to be able to present to some folks who are working on waste to resources as it relates to this year's Envirothon. And I love Envirothon, so happy to support in any way.
Thank you, Caleb. And it seems like compost these days, as you've described it, has become the new black gold in California.
Yep, it's pretty amazing stuff.
Okay, that said, I want to thank you ever so much again, Caleb, and I want to thank everyone who has joined us. And we love that this is recorded. We'll get this up on our Envirothon website as soon as we can. And I hope you join the rep meeting on Monday, Caleb.
I plan on being there.
Wait. There is one. Oh, just someone named Angela is thanking you as well in the chat box. So we're all grateful.
Wow.
Thank you. Thank you, guys. All right, take care. Enjoy the rest of your Saturday. Thank you, Caleb.
Yeah, thank you all, and good luck at the competition. It's coming up in just pretty soon, right? A week.
The 26th and April 2nd is the orals. So yeah, the test is going to be this Saturday. And students, I hope you paid close attention to Caleb's presentation, because there's going to be content, first questions. So you all take care.
Thank you.
Bye-bye.
Right. Thank you. Take care.